Hi, this is Brian with Prophetless Media and Post. Today we're going to take a look at a couple different workflows for exporting out our camera track to other 3D software. We'll be taking a look at the FBX Exporter, lens workflows, and undistorted plates, and a way to export point clouds to our 3D software. We're going to be using Blender for this example workflow, but the issues we will cover should cover almost any 3D software. We'll look at two separate workflows for lens distortion, the Overscan method, which is the default inside of Fusion, and the full resolution undistorted plate method. As this might be long, there will be chapter markers for you to jump around. If you'd like to follow along, I'll put a link down below to the footage we are going to be using. So the first method we're going to take a look at will be the Overscan method, which is the default method within inside of Fusion. Let's add in a camera tracker. I'm just going to add that in. We're going to connect this up, and only thing I need to turn on is bidirectional tracking. And click auto track. Okay, and once that's done, let's go over to the solve, and we're going to do the distortion workflows, which are way more complicated. If you're not using lens distortion, this will be a lot easier, and you can skip ahead to where we talk about the FBX Exporter. So inside the solve options, the one thing we're going to turn on is the enable lens parameters. Once we do that, it's going to start calculating the lens distortion. Turn on that, we can hit solve. Okay, and once that's done, we have an error of 0.703, which is actually pretty good. But let's just clean it up a little bit. I'm going to use the track filtering, select, delete, and let's hit solve again to refine. Okay, and we have an error of 0.3393, which is actually quite good. If for some reason you do the exact same steps I did, but you don't get the same results, you can turn off the auto select seed frames and you can add them in yourself. That's probably what the problem is. Okay, so now that we have the solve done, let's go over to the export, and we're going to set up our ground plane. So under the scene transform, I'm going to click unaligned, and I'm going to come somewhere around the middle here. I'm going to select this one right here as my origin, and then just click and drag. I'm going to shift and select a bunch of trackers that are on the ground like that, something like that. And we're going to use that as our orientation for the ground plane. And then we're going to go back to aligned, and then now we're ready to export. So we'll just click export. Then we have this set up. Okay, so now let's talk about the lens distortion. So if we look at the camera tracker here, come over to the solve, you can see right here we have this lower order radial distortion. We want to copy that value. So if I double click in there, we should be able to copy. We can add in a lens distort node. I'll just add that in. And we're going to connect that up to our main clip. And let's put this in the viewer. Inside that lens distortion model, go to the classic LD model. And we just want to paste that value that we copied in. And press enter. And once we do that, you can see the lens distortion. Now you could see what just happened when I turned the lens distortion on. And if I turn it off, this is the original plate. When I turn it on, you can see that the pixels are actually going outside of the image. So we need more pixels for the actual undistorted plate. Now the way that the Fusion workflow is, this is the Overscan method, which is that the camera is going to be based upon the actual resolution of the original clip. So we can go through here, through our 3D, and when we get to the camera tracker at the end, it's automatically going to be at the right resolution. And we can use, inside the camera tracker, if we go to image, we can use domain overscan for anything that's getting cut off. It'll make a little bit more sense once I start putting everything together. So the actual workflow, let's go into merge 3D and right click inside the viewer, go to camera 3D. So we're looking through the camera, and in the point cloud, let's change that to point, makes it a little bit easier to see. So right now we are actually not looking at this properly. The undistorted plate should be inside the camera. And if we look closely over here, if you look at the, like say these points, maybe I can go a little bit further, like all the way down here, you can see that that point right there that's supposed to be at the bottom of this light pole is actually supposed to be much closer to there. And if I switch the original plate with the undistorted plate, that's where it's supposed to be. We're going to use the undistorted plate just for visually lining it up. We don't want to render it out because we want the original to come back over the top. Let's take this lens distortion. I'm going to copy that because I'm going to need it over here. And we're going to connect this. This will be our final render into the lens distortion. And then this lens distortion, we want the distortion to come back on. And then we're going to merge it over this. So I'm going to grab a merge. I'm going to drop it in here. And this is going to go on top. So when we look through here, we don't see anything. That's because the point clouds are not rendered. So let's make them rendered. And let's we want to take the camera off. So you can just disconnect it right there and that will also work. So now we're getting, this is our point cloud that's been rendered out. Then we added our distortion back on and then it's lining up. So just to check this real quick, let me put my plate back on and say, where's that point right there? Maybe I want to create a shape there. I guess I connected too many pieces. Okay, so this is a shape. Let's turn it into, I don't know, sphere, and then bring it down. And so say we have that sphere on top of the lamp, and you can see now, if I go through, that looks great, right? So when we take a look at the render, let's unhook our lens distortion again, and then we look at our lens distort, it brings it down. And as we get closer to the edge, you can see what's happening. If I come over here close, you can see that it's cutting it off because we're redistorting our image. So in this overscan workflow, in this tracker, all we need to do is come over to image and then move the domain overscan up. And once I do that, you can just move it up a lot or whatever. It's going to render outside of the frame. And then when we put that on top, it's going to be fully on. We can make this look a little bit nicer, I suppose, by, let's grab a spotlight, drop that in. Inside the camera tracker, go to controls, turn on lighting and shadows. And then in the 3D viewer, let's turn on shadows. Oops, I grabbed the wrong thing. I'm just gonna do a little, and we'll just make the cone angle. We'll just do something like that, just to give some light and life to the thing. Okay, so now we have our ball connected there to the 3D space. Okay, and now the 3D scene is working the proper way. So this is the normal way you would do this. So this is the Fusion workflow to work with distorted plates. Now, if I want to take this whole thing, I want to actually do my 3D work in another program, then I'm going to need to export it out. So I'm going to undo this. I'm going to delete that ball. I'm going to leave the spotlight. What we're going to want to do is FBX Exporter. Let's save it as the Overscan. We'll save it as Overscan Cam. So we're going to save it as Overscan Cam. We're going to leave it at the FBX binary. If you click on this, there's actually quite a few different options here. So depending on where you're going, we're going to be going over to Blender. And so this binary is going to work, the FBX binary. The default version, I'm actually not sure what it is. I'm assuming it's the most recent version, but whatever default version it is, seems to be working well. If you use one of these different FBX versions, one of the things that might happen is that you'll get the right information, but your camera will be reversed. And I'll talk about that when we get into Blender. We got our right frame rate. That's what it is. And we're going to export out our geometry, lights, camera. Can leave reduce constant keys. And what we'll do is we'll connect that to the FBX exporter. Now, before I export this out, one of the things I want to point out is this point cloud will not come across. There may be something in Reactor to do this, maybe an Alembic export. I'm not sure. I honestly haven't looked. But a workaround could be to apply small little geometry to each one of the points and then export out that. And so that's what we're going to do. So we're going to take our point cloud off. We're going to add a replicate 3D, and then we'll take a shape and add that shape to the input, and that will, let's connect that up to the merge 3D, and it's totally black. One of the things you can need to do is the point cloud, you got to make sure it's make renderable first. And then in the replicate 3D, you can see it's really large. Oh, I don't want it to be plane, sorry. Change it from plane to sphere. Then when we look through the merge, we just want to make the size of the spheres much smaller. You can see as I go down, it's starting to be more reasonable. Let's put in maybe something like 0.003. I just put in the background for the camera for a second. Okay, so yeah, you can see took all the point cloud and added shapes to it. And then that's going to render out in our FBX exporter. Okay, so I'm going to disconnect the background again. So if you see here, we can see we have our point cloud that will be rendered out. So the FBX exporter is all set, but we also need to send out undistorted plate for Blender to use as reference. And so we're going to leave it at this value right here. We're going to leave it at 1920 by 1080 because that's how this camera is set up. It's set up for Overscan. So I just need to add in a saver. And in that saver, let's browse. Let's go to the desktop. And I'm going to let's add a new folder. This will be the Overscan Undist plate. Put that there. And we don't want it to be EXR. We want pretty easy files. So I'm going to delete the EXR and I'm going to say Overscan cam. We can leave that. That's fine. .0000 dot JPEG. And you can change this to whatever format you want, but I want to start the numbers at 0. So if I place it in here, then numbers will match with our sequence. Okay, hit save. And now we're ready to export out this information for Blender. So to do that, we're just going to go up here, to Fusion, render all savers. And we'll let that go through. And then we're going to jump over into Blender. Okay, so now we're in Blender. First thing I'm going to do is I'm going to delete this stuff that's already in here. And so we have a blank slate. So even though we're using Blender, these are the kinds of problems you're going to run into when you bring it into whatever software you're using, or at least there are things to be aware of. So the first thing we're going to do is File, Import. Let's get our FBX, go to the desktop. We have our Overscan cam. So inside of Blender, one of the things to be aware of is the scale. Typically, you're going to want to scale it up by 100. I believe Cinema 4D is probably the same way. It used to be. I haven't used Cinema 4D in a little while, so I'm going to scale that up by 100, and we can just hit import. Once I import it, you can see we have our whole scene. One of the common problems, there certainly has been over the years, is that the camera would be facing the wrong direction. The animation would be correct, but the camera was just facing the wrong direction. If you bring it in, and that is the case, let me just show you what to do. Just go over to the camera. Oh, in the object, right here where it has the keyframe transforms, just open up the delta transform and change the scale X and the scale Z to -1 and -1. And that will reverse the direction of the camera. Just FYI, I think there's some other videos out there on that. But anyway, it seems like FBX, at least on today, is working correctly. So I'm just going to clean this up. So I'm going to select the first shape and shift select all so that we have all the point cloud. And I'm going to make a new collection and just drag this into that collection. Okay, so let's start talking about some of the other issues we're going to deal with. Okay, so let's select the camera. So everything here is looking pretty good. One thing, let's go to the camera itself, and one of the first things to check, and it's a problem here in Blender, is that the focal length didn't come in correctly. So I'm going to go back over to Fusion. Let's select our camera here, and we can see here's our focal length. If we double click that, you can copy, come back over to Blender, and then paste in that focal length. Press enter. Okay, so now we have the right focal length. Some other things to check are, let's go down here. We have the camera, the film back. This is the right film back inside of Fusion. If we look at the film back, you can see that it's 0.831496 inches. So you can use a converter if you want, but inside Blender, this is the right one. And what else do we have to do? So with the camera, I think that's it. Then we have our background images. So we can put in some background images. Oh, hold on a second. Before I do that, let's take a look at, let's go over to the output. This is another thing we want to check. Our resolution, 1920 by 1080, that's correct. The right frame rate. We have our start and end is 0 to 191. So we're going to check our frame range, and then we'll get into this in a little bit. Let's go back to the camera, and then we're going to set up our back plate. So let's go to background images, add images, and let's open up our Overscan Undistorted plate. So I'm going to grab the first frame, come down to the bottom, shift select the last frame and open it, and that'll automatically turn it into image sequence. And this is another thing that happens in different software. I know this used to happen in Cinema 4D too. It would offset. So when we brought it in, it defaults to frame 1 in Blender. So we just need to bring this over to frame 0. And that should be that. Let's take a look through the camera. Okay, I can't see anything because the ground plane's in the way, so let's turn that off. Okay, so now we are looking through. We got our undistorted plate looking through the camera. Everything looks pretty good, except you can see what happens in the first frame. If we come down to frame 191, you can see the keyframes are off 1. So this is another thing that you have to pay attention to. I think that's why Blender is a good example for this. So I'm just going to grab the keyframes and move it over 1. Okay. And let's see if that helped. Let's go to the first frame. And there we go. Now the animation is locked up. So that's several different steps, but these are the different kinds of things that you want to pay attention to if things aren't matching up the way they are in Fusion. Okay, so that's looking good. We have our point cloud, which is really just a whole bunch of spheres. Let's add a few pieces of geometry in here just to see how our workflow works. So I'm going to add in, I'm going to add in a torus, and let's scale this down. Maybe something like this. And I want to add this to that light post. So holding Command, you can kind of zoom in here. So with this torus selected, hold down Shift, and we're going to select that point right there. And then right click, snap, select to active. And that's going to push it right to that point. So even though this isn't a true point cloud, you can still use it like a point cloud. And then let's add another object over here. So I'm going to add, let's add in, why don't we do a sphere? And let's shrink that down. Oops. Something like that. And then let's shift right there and select active. Okay. And I'm just going to zoom out a little bit. And let's see how that lines up. Okay, cool. I mean, I think that's looking pretty good. Now remember, we're using the Overscan workflow. So we need extra pixels outside of the edge of our image for it to come in correctly and not get cut off when we redistort. This is something that you can do. Inside Blender, it's a free plugin that you can download. It works pretty well, but you would go to your output. And once you download this plugin, I'll put a link in the description below. If you're using Blender as to where this is, you have this option right here called Overscan. Turn that on. And what you can do is just change this percentage a little bit. So I'm going to bring it up. I think all I need is 1% bigger, probably just a little bit. If I have to, I can come back and render it again because this isn't heavy. Okay, so we just have a little bit of extra overscan. That should be enough. Let's say we're ready to render. I'm not going to, we're not going to do anything too fancy here. Another thing we want to turn on. So one of the things we want to just render the geometry and not the background. And we can do that pretty fast. And in here, we just go to the scene section, go to film, turn on transparent. And also under scene, we're going to set up our output. So let's get an output. Let's go to desktop. Let's add a new folder. And this folder will say, Overscan from Blender. Okay, let's just open that up and we'll just click here. Overscan from Blender and just accept. You don't have to add the numbers in Blender. Blender will do it for you. But we have it'll add the file extension and the frame numbers. We have a bunch of choices for different formats. We want PNG and we definitely want alpha. So RGBA. And let's just render an image just to make sure that everything's working out. Okay, so it's not. If I go to the alpha, you can see it's blocked out, and that is because, okay, the ground plane here is still set to render. So I'm going to turn that off and let's render an image, see what it looks like. Okay, there we go. So if I go to the alpha, there we go. We got the alpha, and that's all we need. Before I render that out, I'm going to select these two pieces of geometry, and I'm just going to render them out together so we can check to see how well everything's working across. So I'm going to select those, and we're going to export them out as, let's export them out as an OBJ. And what do you want to name them? I don't know. Blender Overscan, and they're already OBJs. We want to limit it to the two selected objects and export those out. So we're going to export those out, and then now we can render our animation. So let's go to render animation, and this will render the whole thing. I did leave the point cloud in there just to check our workflow. Okay, so we're back in Fusion. Let's open up Overscan objects. So we're going to grab those. I'm going to drop that into our project. We have our Overscan from Blender. So this is our rendered out images. And you can see that the resolution is 1930 by 1090, which is that Overscan size. So I'm going to push this off to the side. Let's grab our Overscan. We're going to drop it right here. Okay, so here's our Overscan. If we bring it up to the viewer, you can see we have everything and the alpha is on there. We're going to need our lens distortion. So let's copy that. Paste it, and this is set to distort. So we're going to do that. And I'm going to just merge this right over the top of what we already rendered out. And let's take a look. So here's our original, and then we move this right on top. And you can see that the pieces are lining up right on top. Now the reason that's working, so we have this 1939, right? Then we have our lens distortion that's bringing it back in. And what's happening is it's using the background is coming in at 1920 by 1080. So it's going to do the crop for us. Could just put a crop after this, but you don't need to because the merge is going to do it because you're putting it over the top. So let's double check this. Well, the other thing we can do, so let's bring our merge here, and then let's take our FBX mesh and drop that in. So here's our sphere and our torus. And if I bring this over like that, you can see they match up. So you can see that everything is lining up properly. So that was a lot of information, but this is how you can work with the 3D camera in Fusion, which means you can use 3D objects with inside Fusion, and then you can also use 3D objects outside of Fusion. You can either render them or you can render out the shapes and render them inside of Fusion, comp everything together using the camera that you tracked in Fusion. Okay, so that is one way. So then the other way we're going to talk about, and I'm just going to take this lens distortion from the beginning, copy it, I'm going to paste it and bring it down here. And let's take a look at this lens distortion. So one of the things that we noticed when we did the lens distortion the first time is that it goes outside of the 1920 by 1080. So it's going to be a little bit larger. So we can add a crop, add a crop. And if we look through the crop, what we can do is let's turn on keep centered, go to auto crop and hit auto crop. And that's going to automatically go out to the furthest edge. And now you can see our image is 1934 by 1088. So the way that this workflow would work is that we would do the lens distortion beforehand. It's not like dedicated 3D tracking software where I can track the original clip at an HD resolution. And then when I get ready to send out my camera, I can use a lens distortion workflow to set everything to the undistorted plate's resolution. But you can work around that if you need to work in this kind of way that you don't, whether you don't have Overscan in your 3D software or for whatever reason you want to use an undistorted plate inside of Fusion, this is a way to do it. So what you would do is you would do your undistortion, set your crop, so you set your range here. Just a hint, I have found that resolution, it's good to keep at multiples of 16, which sounds odd, but it seems to be a good idea. So one way to do that is you can grab, say, a calculator and say we have 1934. So 1934 divided by 16 equals 120, almost 121. So 121 times 16 equals 1936. So we should change this to 1936. There, 1936. And 1088, I believe, is a multiple of 16. 1088 divided by 16, yes, is 68. This is just something that I found, and it's probably because of Synthize has an option in there, and I wondered about it, and I did have a problem working with Blender, and if these were odd numbers, I don't know, for some reason it didn't work. So it's a small thing to do. Change your resolution size to fit that and seems to work a little bit better. Anyway, so now that we have the undistorted frame size, now we would do our camera track. And if we do our camera track on this resolution, then we can actually have the full undistorted resolution plate to work on inside of, say, Blender. If you use this camera right here, it's going to be, and you put this full size undistorted plate in there, it's going to mess things up and it will not be in the right place. So this is really important to understand. So if we were to do it this way, we can do a camera tracker, or we can add it, take a look through the camera tracker. I'm going to do exactly the same thing as I did on the other camera track. Okay, so let's go over to the solver. So we won't need to turn on the lens parameter this time because we've already done that. On 0.67, let's just do a quick track filtering, delete, solve. Okay, 0.35, that's probably pretty good. Let's go to export, go here, same exact scenario. Yeah, something like that's fine. Set that as the ground, click it aligned, and then hit export. Okay, so now we have this scene. Now this camera is set up for this undistorted plate. Let's set up a saver, and we'll connect from the actual cropped undistorted 1936 by 1080. And let's browse. So we're going to add or res, save that. So that's going to be saved. And then we can do the same thing that we did for up there just to check. I can pull the camera tracker out of the way. And we'll do the same thing we did up that we did in here. As a matter of fact, I'll just copy that spotlight. I'm sure it's pretty close. And then we're going to take the replicate 3D, add that to that. We're going to grab our shape, change it to a sphere, set the same radius, 0.03. Okay, and then let's take a look. So you're not seeing it show up. Hold on a second. Let's look through the camera. Let's change that to points. We're not seeing the replicate 3D show up because they didn't make it renderable. So inside the point cloud, make renderable. Now we can see the little spheres. Okay. Now we have our camera. So now we need our FBX export. Add that, and we're going to make this, we'll use the full undistorted res cam. Save that, and we'll connect that to that. So now we can render this out, and I'm going to Command P to shut off this one and Command P to shut off that so it doesn't re-render those two. And now I think we're ready to go ahead and export this out. So let's go over to Fusion, render all savers, and that's going to go through and render these out. We can head over into Blender, and we're going to start with a clean one again. So we're just going to grab that, delete it, and we'll start with the same thing. We're going to import our FBX. So let's go to our desktop. So we're doing the full res. So select that one, scale to 100, import. Do the same thing. We want to grab the first shape, shift, put it into a folder just to make it cleaner. And let's see, we have this projection screen. We can delete that. And the ground plane, let's turn it off and turn it off in the render. So we don't have the ground plane. So okay, so let's go through this. So the camera, look at the camera settings. Okay, it's got the wrong lens. Let's take a look at our render. So this one's got a focal length of 46. So let's copy that and paste. Okay, it's got the right depth field. Before I put in the background images, let me get the output set. So now in this one, we want the undistorted plate size. So in this scenario, we want 1936 by 1088. Okay, so that's going to be the difference this time. This time we're actually going to plug in the resolution instead of using the overscan. The overscan is actually, even though it does change the resolution, it does it with a script so that it affects the way they won't change the projection, basically. Okay, so now we have the right resolution. Let's go back to the camera, and then now let's bring in our background images, add images. Let's open up full res undistorted, grab our first image and our last images and open it up. Same thing, start on frame 0. We have 192 frames, so we have to change the settings here. We could do that right here. This should be 191. And then you can see the keyframes are all moved over the same. So let's just grab the keyframes and move them over one frame. And let's look through the camera to see what we got. Okay. And it looks like everything is lined up correctly. Yeah, that looks good. Did I miss anything? I think I got everything. So why don't we do the same thing that we did with the other one, which was to add in some different objects. So I'm going to add in, this time I'm going to add in, let's add in a torus again. I'll scale you down and do the same thing. We're going to zoom in here a little bit. I'm going to shift click that and then snap section to active, push that over there. And then let's add in, and I'll add in another torus. What the heck? Bring that down like this, and then we'll do one over here. Oops. There we go. Pull out here, and then let's just see if that looks, yeah, it looks about right. So let's see. Oh, wait. Yep. I just want to make sure we got the frames the right way. Okay, so these are ready to render out, I would think. Go to our output, and I'm going to open up this. Oops. And let's add in a new folder. And go in here, and then I just copied that name and I'll put it down here and accept. So that'll be the name of the file. So full undistorted res from Blender. And what else do I need to do? Oh, over in the render, come down to film, turn on transparent. I'm going to leave all the point clouds on. Let's just render an image just to see what's going on. Okay, I think this is correct. Yep, we got our alpha. Okay, I think we're good. I think that's all the steps. So why don't we render this animation? Oh, you know what I'll do? Let's select these two objects and do the same thing we did before. I'll export, put it on the desktop, selected only, and then we'll just make that and export out those. And then we're going to render this scene. So I'm going to render this whole scene. Then we'll go back over to Fusion, see how everything lines up. Let's add in a merge. And we want our original clip to be in here. So I'm going to bring that to the background. I'm going to use a... And then this render is going to go into here. So right now, of course, we got to take this out. We have to redistort. So copy, paste. And in this list, lens distortion, we want distort. And let's just bring in the other objects so we can set the whole thing up. So we have our full undistorted Blender object. So let's grab that guy and put him in. And then we have our full undistort res from Blender. Okay, so here's our 3D object. Let's drop that in. Turn on the lights. So that looks like it's lining up. Okay. So let's see how this all works. I'm going to grab the lens distortion, copy, paste. I'm going to put that in, and then we're going to merge that over. Okay, so that's not really lining up very well, right? We have a different kind of edge here. So what's going on? When we're rendering from here, we're using a camera at 1936 by 1088. That was what we tracked, but we're rendering out cropped. So I think what we're going to have to do is in this camera renderer right here, if we look through here, we need to change this, turn off auto resolution. There we go. Now it should line up correctly. There we go. So now everything's lining up the right way. Okay, so that was a lot of stuff. This is a really much longer than I thought it would be. Yeah, I mean, if you have any issues, let me know in the comments. I try to get back to everyone as soon as I can, as long as it's productive. And thanks again for watching, and I'll see you again in the next video.